Okay, so this is from the 2017 test. This is their number 5, which is a non-calculator question. Two particles move along the x-axis. Okay, between 0 and 8, let's think of that t as time. Between 0 and 8, the position of particle P at a given time is denoted by this. So the word position I'm going to underline. While the velocity of particle Q, okay, so already velocity particle Q is given by this. So two different things, right? One's position, one's velocity, and they're two separate particles, okay? Particle Q is at position 5 at time 0. This is going to be important as well later. Okay, so part A. For time between 0 and 8, when is particle P moving to the left? So I'm going to focus on particle P. Now, particle P is given as a position function, and all that I know, not all that I know, but one thing that I do know is that if I'm trying to figure out left versus right, that is when the velocity is negative. That's something that we've kind of hopefully embedded in our brains. So if the velocity is negative, we're moving left. And so what that means is since they've given me position, my first step is to take this x function. I'm going to use the same notation they did. And I need to find the derivative of that because position goes to velocity, goes to acceleration. So as I take the first derivative of position, I will get velocity. That's my first step. So the derivative of that function over there that's underlined in red, well, let's see, the derivative of natural log is 1 over x, right? So it's going to be 1 over whatever I see. But then that's not just a normal x or a normal t. So I need to take like a chain rule, you know. So it's going to be the derivative. So it's going to be 1 over this times the derivative of this. Now the derivative of this is 2t minus 2. So that's going to actually go into the numerator is what's going to happen when I clean it up. Okay, so there's my step 1 is just taking the derivative to get velocity, and that is my derivative function. And now I'm going to set that equal to 0. Okay, and the reason I'm going to set that equal to 0 is because I then am going to do one of those sign tests. I'm actually going to put my work down here. So here's my P particle, but this is the velocity of P. So I'm going to write velocity of P. Okay, so if I set that to 0, guys, here's the deal. You just need to set the top and the bottom equal to 0 because those are going to be the critical values where something can happen. So, because remember, you set something, if you need a critical point or a critical value, you set, it's when the derivative is either 0 or undefined. So that's why I'm setting the top or bottom equal to 0. So for this one, I'm getting a 1. And for this one, I'm going to have to factor. So let's see, what would that be? Is that really a 10? Okay, so that's 2 times 5. That doesn't work. I wonder if... let me do the quadratic formula. Isn't that fun? Y'all were thinking this was going to be easy, and I was too. Okay, so quadratic formula, because that's not going to factor. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so yay, I'm finished. Now, how do I know I'm finished? This is about to become a negative under the square root, guys, and that just means that it's imaginary solutions. So we kind of lucked out, and the denominator is not going to have any place where it's equal to 0 because of the imaginary stuff. So basically t is 1. So right over here, I'm going to do a number line, and my number line is actually going to go from 0 to 8. Okay, now why 0 to 8? Well, because everything in this problem references 0 to 8. So here's 0, here's 8, and here is the number 1. So what I'm going to do is around the number 1, I'm going to sign test. I want to see if between 0 and 1 if it's positive, negative, and then between 1 and 8 if it's positive, negative, and that's going to give me the answer to part A. So let's pick a number like 1/2. So I'm going to check x prime p of 1/2 and see if it's positive or negative, and then I'm going to check the derivative of x at, let's just say 2, and see if it's positive or negative. So 2 times 1/2 minus 2 over 1/2 squared minus 2 times 1/2 plus 10. Now remember, you don't care exactly what the answer is, you just want to know if it's positive or negative. So that's going to be a negative on the top, and on the bottom that's like a 1/4 minus 1, that's going to be a positive. So a negative over a positive is a negative. Beautiful. Then I'm going to check like a number to the right of 1, which a good one would be 2. You can choose whatever you want. 2 times 2 minus 2. Now all this work that I'm showing, guys, you don't actually have to show this stuff that's in orange. I would show that for sure, that number line, and that lets them know that you're testing it, but you don't really have to show all this plugging in. I mean, you could, and it's smart, and that way you don't make a mistake. But I don't think it would be required for the answer key. So that would be a positive on the top, positive, positive, positive on the bottom. So this is what I'm getting. So on my sign testing, between 0 and 1 is negative, between 1 and 8 is positive. Let's go back and answer A. When is particle P moving to the left? Notice it doesn't say justify. I still want to show that, but honestly, if you just said as your answer, let's see, I would write P, oh shoot, I'm actually going to go ahead and for some reason this is not working out so well. Okay. Sorry, I'm trying to give myself room here. All right. So I'm going to say P moves left from 1 less than t. Oh, nope. I messed up. That's when it's positive. I need to go from 0, don't I? So it's when it's negative. So from 0 less than t less than 1. Okay, so there's the answer to my question. It doesn't say justify, but they're probably going to be looking for the fact that you took a derivative, set it to 0, and then did some sort of a sign test. Okay, so I'm actually going to skip down to see how they allocate the points on that before I go to part B. So there's part A. Okay, so that is worth 2 points. 1 point for did you do the right derivative, and then 1 point for did you get the correct interval. So notice that was important that they show, you don't have to factor that out by the way, but you do show that you found the derivative, and then you want to show down here the answer, the actual answer. Okay, and you know that statement of t squared minus 2t plus 10 is positive for all t. You don't have to write that, just so you know. That's just a side note that they made. But us setting the top and bottom to 0, that would be the work that sort of justifies this as well. So maybe it is important to just kind of show everything that you do. All right, next question. I'm going to do some erasing. Let me pause while I erase. Okay, so part B. So same thing. For t between 0 and 8, find all the times t during which the two particles travel in the same direction. Okay, so this is still a left versus right situation. We already know for particle P that we're moving to the left here and we're moving to the right here. We need to do the same thing for Q. All right, so I need a number line for the velocity of Q. And if I can do the same thing with Q, then I can like look at where these things overlap. I'm going to notice I'm lining up the 0s, I'm lining up the 8s, because I really do want to see the overlap on top of each other. I'm going to extend this line right here. Okay, so let's do Q. All right, so luckily they already gave us the velocity of Q. We don't have to take a derivative because they've already done that for us. So at this point, we are just taking t squared minus 8t plus 15, and we are setting that equal to 0 or undefined and solving. Hopefully this one factors. Let's see, 3 times 5. How about minus 3 minus 5? So t equals 5 or 3. Beautiful. So on this one, I know I've already got from above, I've got something happening at 1, but you know, that's fine. But on this one, I really care about 3 and 5. So I'm going to do the same thing where I'm going to draw my little lines through 3 and 5. And on this one, I need to sign test around these, okay? So basically, I need to check a number like 2. I need to check a number like 4 and maybe a number like 6. So I'm going to check 3 different values. So I'm going to do some quick mental math here. And what I would show on my paper is just VQ of 2. And then I would show, is it positive or negative? VQ of 4, is it positive or negative? And then VQ of 6. All right, so at 2, if I plug that in to this function right here, okay, so just some mental math, 2 squared, so it's 4 minus 16 plus 15. So that's going to end up being positive. At 4, I'm going to have 16 minus 4 times, that's 32, plus 15. That's going to be, what is that going to be? Ooh, that's 31. That's going to be negative. And then at 6, 36 minus 48 plus 15, that's going to be positive. Okay, so I've got a positive over here, I've got a negative over here, and I've got a positive over here. Now, when you're comparing 2 of these together, it gets a little overwhelming. So sometimes it's smart to just write a bunch of symbols. Like, in other words, I know it's only negative between here and here, but everywhere else to the left or to the right, it's positive. So feel free to just put a bunch of plus signs just so you can see what's happening. Same thing above. Earlier, there was only a negative in that little area, which means everywhere else it's going to be positive. So maybe just put a bunch of those signs so that you can kind of cross-reference them. And then we just look at where things match and where they don't, because this says when are they traveling in the same direction. So like between 0 and 1, they are not, because this is negative and this is positive. But it looks like this little piece, they're the same. Those differ, right? But then those are the same. So my answer would be, my answer would look like this. P and Q travel in same direction. When, and then I would just do the intervals. Let's see. So what was that? That was 1 and 3. So 1 less than t less than 3. And 5 less than t less than 8. If you want to do intervals, you can. That would make sure you use parentheses though. Okay. And if you do that, I would be like, I would actually write when t is, or t intervals are. Like, try to be specific when you're giving interval notation. Something like that, okay? All right, and so let's go see how the points are allocated on part B. Okay, so what they're showing here, this one's worth 2 points. 1 point for the intervals, so that sign testing that I was telling you about, okay? So the same thing we did. And then the analysis using V and Q. Okay, so you're only going to get a half credit if you only showed one of these, you're going to get a half credit. And if you don't show either of these guys, you would get no points. So even if you had the right answer down here, they're saying that you would not get any points because there's no analysis to prove it, which this is your analysis, okay? So definitely showing work is a big deal. Hopefully that stuff makes sense there, but let me know if it doesn't. All right, so we're going to move on to part C. Okay, part C, find the acceleration of particle Q. So I'm going to stop right there. Okay, acceleration of Q. Well, they've given us velocity of Q. So to get to acceleration, I know I'm going to need to take the derivative of what they've given me because that is what is equal to acceleration. Okay, and I'm just going to write myself a little note there, but I know that's true, so I need to take the velocity derivative. And then they want it at time 2. So what I'll do is just go ahead and take the derivative, and then I'll show myself plugging in the 2, and then I'll read part 2 of the question because I'm not even there yet. I'm just working on this fella right here, okay? So the derivative of this one is 2t minus 8. And then I would show myself plugging in the 2, and that would be -4. Okay, so that's the acceleration. Now, up above, guys, they actually did not give us any units. You know, they didn't tell us that this was like meters per second or anything like that. So I don't think I'm going to need units. It is acceleration though, so technically it would be like units per time squared, but I don't think I need to write that. We'll see in just a second when I look down below. I think you can just give the number, but we'll find out in a minute. Okay, so let's see. So that what did I get? -4. All right, cool. So now let's do part 2. Is the speed of the particle Q increasing, decreasing, or neither? Explain your reasoning. Okay, so speed increasing or decreasing. This was those memory tricks that we had, or that I have. You may not ever use them. VOSI or VOD was what I did in the beginning, where velocity and acceleration are the same, you're increasing. Velocity and acceleration are different, you're decreasing. So I need to check both velocity and acceleration to see if they're the same sign or if they're different signs. Well, I've already got acceleration, right? So I'm going to actually start with writing that the acceleration of Q at time 2 is negative. And you can write, I guess the best way to write that it's negative is to put that it's negative, like it's less than 0, okay? And then I'm going to write what the velocity of Q at time 2 is. And I'm going to see if it's positive or negative. So how do I show that? Well, I just show myself plugging it in. VQ of 2 squared minus 8 times 2 plus 15, 4 minus 16 plus 15, that's going to be a positive. So that is greater than 0. In fact, I may need to add to this V prime Q of t because I want to use their notation as well, you know. I should have used a 2 here. Okay, so their notation, it would be a V prime, and that is acceleration, and that's less than 0. So one is negative and one is positive. So what I'm going to say is the particle Q, I'm going to say particle Q is decreasing, or particle Q's speed, sorry, I left out a word, is decreasing at t equals 2 because, and then I would write that. Okay, so that would be what my sentence looked like. Or I guess if you wrote that first, you could always do one of those things where you say something like because, and then you show that work. You could do comma, therefore, that might be easier because you will have already done that work. So I would do like, therefore, particle Q's speed is decreasing. Okay, so if you've already done the work, don't do the because. Start with the because and give a therefore. All right, let's see how we did on C. C, we would get, let's look at their points here. Okay, so what they're saying here is that that you would show the derivative and you're going to get a point for doing acceleration at 2, guys, okay? And then another point for saying the reasoning and the fact that it's decreasing. So literally this looks just like our paper. Now they put less than, they put what it equaled. You really don't have to, but you could, it doesn't matter. At time t equals 2, the speed is decreasing because, beautiful, okay? So we would have gotten our points, okay? Now we look at part D. Okay, part D, find the position of particle Q, okay, position of Q, the first time it changes direction. So this is going to make us have to sort of call upon a previous answer. Look back at, I guess it was part B when we had to do our sign tests. And we already found when Q changed direction. I believe Q was the one that changed directions at 3 and 5, right? Wasn't that 3 and 5 for this one? So basically when T is 3 is us trying to figure out what the heck is happening. So, and it wants the position when it changes direction. Okay, so here's what we know. This is where this thing's going to come into play, okay? So when T is 0, I know that the P of T, the position, actually I can't use that notation because they didn't. What did they call that? They called that X of P. Okay, so the position of the function was 0. So in fact, I could write the position when T is 0 was equal to 5. Okay. And they're asking me to find, okay, they're saying, okay, now find the position when time is 3. So hopefully that makes sense because that was our answer to number B, but we've got to figure out how to do a change in position. All right, so this comes down to integrals, right? To find the change of position, guys, what we're doing is we're looking at the distance traveled between those two, all right? Now, the reason it's going to come down, actually, you know what? It won't come down to an integral because this is already a position function. So I guess, yeah, sorry, I was thinking that this one was the one that they had given us velocity, and we were going to have to integrate to get position, but we're not. Oh, hell, we are. I started using the wrong thing. Okay, I am so sorry. I was looking at 2 different functions at the same time. Teehee. It wasn't the X. If y'all were confused, I am so sorry. Y'all, I goofed. Okay, I started mixing up the Q and the P. This is why I have to circle and box everything. Okay, particle Q, y'all, is this equation, not the other one. I got them totally mixed up. So, yes, so I should have written a V of Q here. I should have written a V of Q here. But also it's not really that, okay, it's not really that the V of Q of 0 is 5. It's the position is 5. So the velocity is not 5, the position is. So my notation is just absolutely atrocious right now. I wish I could edit this video and go back, but I'm not that good with this technology yet, so y'all just have to suffer with me. Okay, so here's what I know. Ha ha ha. Okay, I'm just going to write it in words. Okay, so when time is 0, the position of Q is 5. And I need to know when T is 3, what is the position? All right, so this is going to be an integral problem because I have velocity and I need position. So what I'm going to have to do is I'm going to have to integrate the V function above because right now, guys, this is velocity. And if I take the integral of it, I get position, right? Now, what are my bounds? Well, my bounds are, I need to go from what they've given me, which is 0, to where I need to stop, which is 3. And this finds a change of position taking that integral. So what I'm going to do is I'm going to write this, and that is going to be the change of position. But what I also need to consider is what my starting position was. Because this just gives me change of position. I need where this started so that I can find out where I end up. So based on that, the starting position was 5 when time was 0, right? So this is going to be my answer. It's going to be, in fact, I would write it as, I'm trying to think of the notation for the position at 5. What notation should I use? I'm trying to show that I'm doing an integral of that to work backwards. I guess I could do, maybe I'll call it x. No, I don't want to give it a name. We'll figure that out in a minute. All right, let's go ahead and just do the math. So I've got 5 plus, so now I need to integrate this. So the integral of this one, okay, would be, so it's t squared, so it would be t3 over 3 minus, and then there was an 8t up there, so minus 8t, so that would be 8t squared over 2 plus 15t, and that's the integral, right, okay, between 3 and 0. So that's going to be equal to, I'm running out of room, 5 plus, okay, so we need to plug in the top. If you've forgotten how to do this, you'd plug in the top bound, and then you plug in the bottom bound, and you subtract. So in the parentheses, I'm going to plug in the 3. So 3 cubed over 3, so that's going to be 27 over 3. So that's going to be 9 minus, I'm going to plug in the 3 here, 9 times 8 is 72, gross. And then plus 15 times 3 is 45. Okay, so there's all of that minus plugging in the 0. Well, when you plug in the 0 to these, it's actually just going to all end up as 0. So that's actually exciting. Okay, so let's get a number for this and then we'll be done. So 5 plus, let's see, 9 plus 45 is a 54. What's 72 divided by 2? That's got to have a pretty answer, right? 72 divided by 2. Sorry, I'm trying to do this in my head. I should write it out. That would be a 36. So we have 36 and a 54. So 54 minus 36, that would be 18. Is that right? Yes, that's an 18. And then plus that 5. Oh my gosh, I hope I did this right. Okay, I'm getting 23. Woo! All right, let's go down and look. I'm at that point where I'm over this. So let's go look and let's see how many points we would have gotten for this final one. Okay, part D. Particle Q first changes directions at time equals 3. You're going to get a point for the antiderivative, meaning did you do this part right? So you better show that work. Uses the initial condition. That's the 5 nonsense that we were talking about, and then the actual answer of 23. Is that what we got? I don't remember. Yes, we did. Sorry, I know I'm making y'all motion sick. That's what we got. Okay, cool. So we would have gotten our 3 points. Now, notation is where I was struggling. So let's go and look at this. All right, let's see how they did that. So they did call it an X. I wasn't sure if we were allowed to do that. Okay, so we are allowed to do that. We're allowed to just go straight back from velocity to position and call it X. Now, the reason they called it X instead of P is because that's how they handled the other one. So, I mean, my gut would have said P of Q for position, but they wanted us to use X of Q since it was moving on a left and right, sort of a number line. But yeah, they're just showing us initial position at 0 plus that, and then they're filling it all in. So do you have to have this? I don't know. I'll go read and look at some tests to see if they would have still given you the point. But based on looking at these, I feel like the notation on this one is not as important as showing these 3 things. I think we would have gotten all of our points. All right, so sorry about the mess up on part D initially. Hopefully I didn't thoroughly confuse you, but live and learn. And good luck to you guys trying your own little problem.